Good afternoon to everybody.
Good afternoon, sir.
Good afternoon,
So
sir.
what are we going to do today? Shall I continue test of hypothesis?
So we can revise.
No, sir. Revision class, sir, please.
सर
You
आपका
want the
रिवीजन क्लास
revision
क्या
of?
था?
What revision you want?
So we can have a revision class just before the test if everyone agrees.
Probabilities?
Sir, probability along with to the central limit theorem, sir. It can work, sir, because the probability is a very limited concept, na, sir. We can, and in the revision we can also manage to read something about the central limit theorem too. So, both these topics, sir.
Okay. So I will be revising today the work of probability computation that will definitely help you for the test. Complete the syllabus up to module 4 will be the test. Keep in the mind. So let me start looking the question paper of module 4. Histogram I have already told you. So now let us go directly for probability. Probability is a number. And that number is associated with a random experiment. For example, tossing of coin is a random experiment. Probability of happening head is 1/2. So this 1/2 is a number for getting head. Probability is a number all the time between 0 to 1. Tossing of a die. A die has 6 face values. 1, 2, 3, 4, 5, 6. When I toss the die, probability will be 1/6. So the denominator is total possibilities in the random experiment, and the numerator is a favorable outcome of your characteristic. So we say probability is a proportion. Numerator will be always less than denominator. Probability never be 0, never be 1, because your experiment is random. Sample is a random phenomena. "52 playing cards. Probability of getting a spade card will be 13/52. Because 13 cards are favoring for the characteristic spade. 52 is a total. A class consists of 60 students, of which 25 are BCom graduate. Class is of 60 students and 20 are BCom graduate. A candidate is selected by roll number. So probability that the roll number belongs to the BCom graduate. It is BCom graduate is denoted by 20/60. Therefore, for a very random experiment, testing of hypothesis is also random experiment. So to learn testing of hypothesis only, we have started probability work. And it has applications in real life. So understand the revision that I am going to do on different type of probability evaluation procedure. Different type of probability evaluation procedure. Syntax, very important, because in class test also I can ask questions on syntax. So let us start with the very first probability experiment, binomial experiment. Binomial experiment is when your outcome will be belongs to either success or failure. Whereas normal distribution is when variables are non-countable. measurable. So in binomial experiment, either the random experiment will favor you or it will not favor you. So we call success and failure. Sample size is fixed. That is, how many times you are doing the experiment is called sample size. How many times you are repeating the experiment, it is called sample size. Again, a roll number is a binomial data. If I choose 10 roll numbers, it is a sample data. So each roll number is a binomial repetition. Either the roll number belongs to boy or it belongs to girl. So n is fixed 10. A customer is a binomial data. If I take a sample of 20 customers visiting the shop, it is n time I am repeating the binomial. Customer will either prefer the brand or he will not prefer the said brand. Ten people are standing in a queue for a bus. Each one is a binomial data. Either the bus they will get or they will miss. So we call one parameter of binomial distribution is sample size n, small n. Next, each observation is independent. Independent in the sense that the roll number selected first, nothing to do with the roll number going to select second time. Therefore, every observation in sample will be independent. Because it is a random experiment, there can be a probability of success and there can be a probability of failure. P and 1 minus P. And X is how many are successes in the sample are the different characteristic in binomial problem. Clear the characteristic. Is it clear? All the characteristic.
Yes, sir.
Any question? Chetan? Rahul Goswami?
Yes, sir.
Is it clear all the characteristic?
Yes, sir.
Very well.
Yes, sir.
No problem?
No, sir. No problem.
Okay. Banu Sharma? Banu Sharma. Okay. Akshat Sen?
Yes, sir.
Is it clear all the characteristic?
Yes, sir. Even the same.
No problem?
No problem, sir.
Repeating, in binomial experiment, each outcome is a success or failure. Each EACH. Such n time I perform the experiment, it is my sample data. Number of successes in the sample is denoted by X. Small p is the probability of getting one success. 1 minus p is the probability of getting failure in the same trial. And evaluation of the probability will be NCX, p raised to x, 1 minus p to the power n minus x is the mathematics. Without this probability function, you cannot generate different probabilities. Then, using R, how to answer questions related to binomial is the next work. If you identify a given situation as binomial, how to answer the question? How to plot graph? How can you show the answer on the graph? And etc. So, let us see the first question. State the probability for 0, 1 or 2 successes, plural, in 6 independent trials where probability of success is 0.3. So n is 6. P 0.3 and x is equal to 0, 1, 2, 3, 4, 5, 6. This is given. And that I can explain in a different way. Six customers randomly observed in a restaurant. So success means the customer will prefer coffee. P means the randomly selected customer prefer coffee probability. And X is number of customers preferring coffee in the sample are the different characteristic in the question. They are the different parameters in the question. X is equal to 0, X is equal to 1, X is equal to 2. These are individual probability. Each one is a simple single probability. Let us see next question. Probability of producing a drill 0.95. A means singular. Perfect drill is 0.95. 5 drills are chosen at random. So you are observing 5 different random drills.
Excuse me, sir.
Yes.
So I'm so sorry to interrupt, but could you please solve the question with the syntax alongside so that.
Yes, I will be doing.
Okay, so.
I will definitely answering everybody's question. I will be doing.
Thank you, sir.
What is the probability that 3 are perfect? 4 are perfect. 3 or more are perfect. So this is binomial, but C part is cumulative probability. 3 or more. So either 3, 4, 5. Let us see third one. 4 students each have about 80% average in the course so far. That is 80% is a very good number associated to the student. This means probability of maintaining or improving their average is 0.8. What is the probability? All will maintain the average. Exact probability. And so on. So each of these 3 questions I am going to work once again using R. After your understanding of all the questions, I am going to do real life uses of binomial distribution. How binomial distribution will help in real data. So in 2 steps, in 2 stages, I am going to do revision for you now. Okay. So let me go for my R. Question number 1. 6 customers and the number of customers preferring coffee in sample of 6. Either nobody, 1, 2, 3, 4, 5, 6 possible. Denoted the variable X. Denoted by the variable X. I denote PBD, probability binomial distribution, for each value. So exact probability syntax is D binom, not cumulative. How many probabilities I have to evaluate? How many probabilities I have to find?
So 7, sir.
7. What is the probability nobody will prefer coffee? What is the probability exactly one of them prefer the coffee, etc., etc. 7 probabilities. And how to find out? The syntax is D distribution, binomial. Syntax, variable X, comma N, comma P. That is the algorithm. So let me compute that first. Seven probabilities are in the console. Probability for 0, 1, 2, 3, 4, 5 and 6. For which value probability is high?
The 2, sir. Like,
Wrong. Wrong.
So 4.
Which value of X probability is very high?
4, sir.
Wrong. Answer is wrong.
2, sir. 2.
Yeah, for 2 it's 32.4, no?
Yes. So for which value?
2. X equal to 2.
2. X is equal to 2. Perfect. For which value of X it is a very least probability?
So x is equal to 6.
Correct. Which function gives me the answer?
D binom, sir.
D binom.
Correct.
D
So
binom.
what is the purpose of D binom? Evaluation of exact probability. Now the same thing I can plot on the graph because you saw central limit theorem for testing of hypothesis completely by graph. So probability, wherever we say there is always graph. Plot. Y-axis will be probability, x-axis will be the range. And type in quotation O, that means marking the point on the graph. Marking the point on the graph. And each point is for each value of X. So AB line. So whatever probability you got is shown on the graph. Clearly, you know, for X is equal to 2, probability is very high. This is what the concept we used in testing of hypothesis also. Question if any. I have computed the probability. I have plotted that on the graph. From the graph, at a glance, you can see where is the high probability, where is the least probability, etc. The vertical line and the intersection on the graph gives you probability for X. And in your first question, it is asked individual probability. X is equal to 0, X is equal to 1, X is equal to 2. That's all. So instead of writing X, you put the value and write in D binom, you will get the probability. P0 for X is equal to 0, P1 for X is equal to 1, P2 for X is equal to 2, and the function is D binom, exact probabilities. Exact probability. See, this is what question number 1. Can anyone tell me how to plot this probability on the graph? Anyone?
Sir, histogram.
Okay. By histogram. Further.
Sir, bell curve.
Bell curve. You can see now how this work I will be doing slowly. But this is question number 1. This is question number 1. Suppose in your class test for multiple choice question can be any. So you prepare the output on the screen. Now each question you look, read, understand and search the answer and tick mark. For the question, you prepare the output on the screen. Editor, graph and cursor. Okay. Now read the question one by one. Sub question I mean. And for that answer will be available on the screen. Choose it. Which one is correct in the option? Easy. MCQ will be simple. Only thing you require the correct output on the screen. This is what question number 1.
Sir,
Yes.
instead of finding the P0, P1 and P2 separately, like we have done one thing which is like from 0 to 2, can't we do apply?
We can do. That's what I'm showing on the next question. Slowly.
Okay.
You can do. For example, here itself I will show you. Say here. So now I want the probability for 0, 1 and 2. So I say the new x value or I say a range to evaluate the probability. Okay. Range C 0, 2. In 0 to 2. 0, 1 and 2. Is that clear? Now, binomial probability for the range. I denote the binomial distribution for the range. The binom range, 6, 0.3. Get the output. See the output now. Are not you getting the answer?
Yes, sir.
So either you find individually or define the range. Suppose I want to plot this on the graph. AB line vertically equal to range, comma, color, red. Let us see whether we get it or not. Oh, error, unexpected. We arrange.
Is it DBA range?
Yes, please.
Got it.
It has not shown.
Sir, I think
Red color
V
we
is
already
equal to
have.
DB range, DBD range would be
No,
when
no,
we write that.
a DB range will be probability.
Syntax seems to be another DBD range.
Yes.
DVD range, I think that is the problem, sir.
Yeah.
I don't know if the
Okay.
exact
But
syntax.
sir, DVD range is just a name, na sir. Like what is
D will be my range C0 to 2. That's correct. Na 0, 1, 2. Vertically, I want this. Let me
So,
check.
sir, V is equal to DBD range, then it would, I think that's the V is equal to range की जगह V is equal to DBD range होगा, then we'll get the plot graph.
I am doubtful. Let me verify.
The change color red was already there.
Yes, sir. Red color we have already used for the entire question, so
That's why I'm highlighting.
we segregate the range part.
Hey, probabilities I got, which means I can plot it. So these probabilities I have to show for my range variable.
So if you change the color, it'll show.
Yes. Yeah. Yes. Thank you. Very good. Who gave me this answer?
Sir, I
Very good.
she.
Okay. So this is what learning. If we would have met in the class, we would have enjoyed more.
Sir, I
You
have
would
a
have
question.
Yes, please.
Sir, right now what we're using this AB line for is to draw lines on the graph, right?
Correct.
Now suppose we had two graphs at the same time. Like suppose I had run some script and I had two graphs. So how can I how can I make sure that this AB line
wait.
adds the line on a particular graph and not the other one?
Yes, it is a multiple graph. I will explain you. Wait. Let us complete systematically now. Okay. So somebody asked me, sir, why don't we compute for 0, 1 t at a time? I have done it. And I have shown that on a graph by a different color.
So what does
red-
DBD stands for?
Yes.
What does DBD stands for? Binomial distribution. What is
Distribution of binomial distribution.
Okay, sir.
D stand for distribution. D binom. Any variable you can use, not necessarily like what I have used. I simply write R. See now. I can simply write R. Still my answer will be the same.
Sir, I have a question.
Yes, ask. Ask.
So in the plot function where we write type is equal to O,
Oh,
can
yes.
we
Yes.
use
Yes.
something else in it? It doesn't work.
Yes. Suppose if you put L, mostly it will work, but it will not show the intersection. For example, suppose if I change that O to L and see my plotting. L means join the lines. देख लो. And if I plot a AB line, I will get the intersection. So that intersection part I want to circle. So I just denote it by small o is the syntax in R. See. Clear?
Sir,
Yes.
as you are saying, like instead of writing DBD range, we could have written as DBDR. So is it for only our convenience that we could understand the syntax very well, or is it something like a computer?
No,
Or
it is not compulsory. You can write any variable which you can understand.
Okay, sir, got it. Thank you.
Is it clear? Left hand side of the assignment symbol can be any variable which you can understand. Right hand side should be proper syntax. Okay. Is it clear? Question number 1.
Yes, sir.
Any doubt?
No, sir.
Okay. So let us go for next question, and slowly we will change as per the question how to work. And in question number 2, it is given 5 independent drills. They are perfect, or they all are not perfect. So the variable will be 0, 1, 2, 3, 4, 5. Variable will be 0, 1, 2, 3, 4, 5. Already I have used x. So here I denote x1. Repeat the work. This is what the individual probability as well as their graph. But another function I have to explain, that is addition of probabilities as x increases. So P binom is the syntax for cumulative probability. On the screen you can see as in question number 1. So P binom will give you cumulative probability. What does it mean? CUPBD, that is cumulative probability binomial distribution. Second question, that is 2. Who can explain me the first probability? In the console, you have the probability. Who can explain me? What is the first answer?
The one at the bottom or the one at the top?
Yes.
The one at the bottom?
Yes, from first to the last.
So, sir, it's basically saying the probability of the first value is, let's say, 0. Multiple zeros 315.
Yes.
Then the probability of the first event, that is 0 success and 1 success, becomes the second value. Probability of the first, second, and third basically is 0, 1, and 2 successes becomes the third value.
Yes.
So on and so forth.
So on, last probability will be 1.
The probability of any of the occurrences occurring.
Yes.
And hence, obviously, it will be like 100%.
Correct.
1.
Yes.
So it's the cumulative probability
Yes.
function.
As x increases. It is addition of probabilities. D binom will give you exact probability. P binom will give you cumulative probability. You can plot both, no problem. So plotting syntax will be same. Plotting syntax will be same. but computational probabilities are different. Now, what is the question? Exactly 3, exactly 4, and minimum 3. Exactly 3 drills are perfect. Exactly 4 drills are perfect. 3 or more are perfect. So, D binom for the first two, 1 minus P binom for the last. Why? Why? The last will be 1 minus P binom.
So it's because it's 3 or more.
Yes, so 3, 4, 5. So I have written here 1 minus P binom. Why?
Because we minus 0, 1 and 2 from
Correct. Because P binom will give you cumulative probability from least to cutoff point. Correct now?
Sir, how are we subtracting 0, 1, 2? अगर हम 0, 1, 2 subtract कर रहे होते तो we should have written 0:2 now for that.
cumulative
P binom.
Got it.
P binom will give you probability from 0, 1 and 2. Just now I said. And get the output. Or there is an option. As I defined range, define the range 3 to 5. Compute the D binom and the sum. That also I have shown on the next step. See. Third part. Alternate procedure is the range will be 3, 4, 5. Compute the D binom for the range, add them. That means sum parenthesis D binom 3 to 5, 5, 0.95. Instead of 3 to 5, you can type their range also. It is your choice. My answer will never be different for the third part.
So here instead of sum D binom, we can use P binom.
P binom.
Yes, sir.
Let me do it and show what happening now. Check karo. Let us see. Good that you have asked. Let us see. Very good question. Let us see whether we get the answer. What do you got? What do you got? Cumulative probability you got again. 3 ka probability, 3 plus 4 ka probability, and 3, 4, 5.
So no, sir, not 3 ka probability. It is up to 3, sir. Like 0, 1, 2, 3, and then up to 4, and then up to 5. Like because we use P binom, na sir.
Yeah. So best way, sum. To avoid all the confusion, you go for sum. Sum and D binom. Finished. Individually compute it and add. So your probability evaluation can be done by algebra, 1 minus etc., or can be by syntax sum of individual probability for the range. Individual probability for the range. How many of you follow both the procedures? Any question?
No, sir, all clear.
Sir, I have one question.
Yes.
So, sir, it's actually regarding the function plot. So under
Yes.
that, when you type, okay, then you say equals to. After that, in one occasion you use 0, whereas in the other one you use 1. What's the difference?
So what happened, I will tell you. In my version, sometimes if I write L, it will give me O. Sometimes if I write O, it will give me sometimes without intersection. So it is a minor problem in my version. Doesn't matter. You choose whatever you like. Okay?
Okay, sir, sure.
Mine is a pretty old software hai. Change karna padega.
No,
Okay.
Sir, sorry, sir, but,
Yeah.
but like just to be clear, I'm not asking whether it's a 0 or an O. I'm asking if it's a 0 or a 1. What's the difference?
One nahi hai. L. 0 nahi hai. O. L.
Okay, so what's the difference between the O and the L?
That is
On the
what I
plot.
say. If I don't write O and suppose see here. Suppose in this question I check L. Okay? And I plot it. Let us see. I am getting only line. Cutoff point is not shown. Correct, na?
Yes, sir.
Isn't it?
Okay.
But if I write O and if I plot the graph, it gives me the cutoff point, intersections.
Okay, sir, got it. Thank you.
Only to show graphically the probability part, that's all.
Okay, sir, got it, yeah.
Unless we identify that on the graph, y-axis I cannot read, na? So better go for O. So graph also you will get, lines also you will get, etc. Any more question for number 2?
Sir,
Yes.
I didn't get that part. Like when we wrote P binom instead of sum D binom, so why didn't we get cumulative frequency if P binom shows is basically for cumulative frequency?
Because we want here addition of 3, 4, 5, na?
Yes, sir.
But if I use P binom, it will add up cumulative probability for 3, it will add up the cumulative probability for 4, it will add up the cumulative probability for 5. You have seen the answer now, see na. Suppose somebody asked me na sum, cancel karke dekho. Dekho. See the answers. P binom. Okay. Now see the output. Now see the output. What is the first probability? What is the meaning of the first probability? Point
So we
0.
can use P binom as P binom 5 minus P binom 3.
No.
Was it
That
really the same answer, man?
is algebra. Hey, I am asking for this output. P binom 3 to 5, 5.95. What is the first probability I am getting?
0.022.
What is the meaning of it?
It means that we are getting probability till 3.
0, 1, 2, 3 ka probability.
Yes.
Now, what about the next?
It's still 4.
Next, last.
It's still 5.
This is not the answer of our question.
No.
This is not the answer of our question.
Yes.
So we have to go for sum. Or as you said, algebra. That also I will show you.
Okay.
Sum. Instead of P binom, compute D binom and get the output finished. Finished. Now, as you said, or another method, probability for C, second option, is P by norm 5, 5, 0.95 minus P by norm 2, 5, 0.95 is the algebra. See the answer. It will never change. It will never change. It is not going to give you different answer. Because you are finding the probability of 5 and from there you are subtracting for 2. So the rest will be 3, 4, 5, A minus B. A will be larger than B. Any other question now? Very good class. Any other question? Shall I go for next question?
Yes, sir.
Okay. And the next question is 4 students. Example. 80% chance they have done so far better. Evaluate the probability for all of them. P binom. No cumulative concept at all. No cumulative concept at all. Number of students in the sample of 4. All of them still doing better. 0.4096 is the probability. This is individual probability, all 4 of them. So you got now 2, D binom as well as P binom. Let do the same question for 10 students. So Y1 will be 0 to 10. Probability will be 0.8. Compute it and plot it. Total, how many probabilities are computed?
11.
Correct. This is the graph. Compute the probability 3 to 7. Minimum 3 students are doing better. Maximum 7. So what is the range?
Three to 7, sir.
Correct. So instead of 3.7, I write 3, 4, 5, 6, 7. Compute the probability. Plot it on the graph. Compute the probability and plot it on the graph. If I type the answer, that also I can get. Probability for Y, first option. See, answer is this much. 0.322125. That is addition of the vertical lines gives me probability. Second question is 9 and 10. This is the probability. This is the probability you have. 0.3758096. 0 to 8. So everything is a repetition now. Probability will be PY3. By using algebra also you can do. 3 to 7 is 7 minus 2 probability. 8, 9, 10 probability will be 1 minus P binom. And up to 8 is P binom. Same answer. Is that clear? See? Same answer you will get. So D binom you know, P binom as well you know.
So just a question.
Yes.
Next to the variable PYA.
PY1, probability for first option.
Yeah, correct, sir. उसमें ही you have written P binom when you have given the parameters and the argument. After that, what is that dash P binom which you've written?
Which one you are talking? PY1.
PYA.
Yeah. That is P binom for 7 minus P binom.
Okay, oh, that's a minus. Okay, okay.
Minus P binom 2.
Okay, sir. Okay, sure.
Up to 7 cumulative probability minus up to 2 cumulative probability. Any other question? Any other question?
No, sir. You can proceed.
Yes. Now we left with 2, R binom and Q binom. Attentive. I want to choose 10 students out of 100. Rather, 100 times I want to choose sample of 10 each. How many of you follow the sentence? Because now I have to explain you the real life problem. And the real life, you are not doing just one sample, plenty. Plenty samples. So, see the sentence on the screen. 100 times group of 10 students each. That is the R binom.
So what is the difference between R binom and iteration that we use?
Yeah.
Like in iteration also we take multiple
Yes.
times, like 500 times.
Yes. In R binom, it is not probability evaluation. It says generate X data. Generate X data. What do you mean by generate X data? If I have a sample of 10 students, what are the values of X?
Zero, 1, 2, 3 till 10.
Up to
Up to 10.
10. Suppose it is 5 in the first 10 students. Is it necessary in the next 10 students it is 5?
No, sir.
No.
No, sir.
I told independent. So whatever happening in the first sample need not be same for the next sample because samples are random. So suppose if I do the selection 100 times, what are the X values? That is what R binom generate. See now? How many values you can see on the screen?
So 100.
Correct. What is the your sample may be different from mine, okay? Because everything is random. So if you generate 100, your value need not be same as my value. Okay, but you see the screen, what is the meaning of 8?
So 8 is a sample.
No, sample is kitna? Sample size is?
100.
No, sir. 8 is actually out of 10. Like if we have to
8 out of 10 are? Come on, 8 out of 10 are?
Like if there is, sir, if we select like if it is a 10, we have the data of 10, then n is equal to 10.
8
then
out of 10 are successes.
success, yes, sir.
Next, 9 if you look, what is the meaning?
So 9 out of 10 are successes.
So in each sample, number of success will be different.
Yes, sir.
Can't I plot a histogram for this?
So we can.
So could you please repeat the success part again? Like what these numbers are?
Yes. I am selecting a sample of 10. That is part in the question, correct na?
Yes, sir.
But I can select another sample of 10 also.
Yes, sir.
This way, if I go for 10 samples 100 times, how X values are? How many successes in each sample? And that is observed by R binom.
Okay, sir, got it.
Suppose if I plot it, let us see what we will get the graph. Where will be the concentration of the samples more?
So to the right.
Correct. That means more and more times if I do the sample, more and more successes are happening. Correct, na?
Yes, sir.
This type of concept is the one I used in testing of hypothesis. So, once you have a data, you can find the mean, you can find the standard deviation, etc., 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 etc. You can prepare the table and so on. So, what is R binomial tells you?
So values the sample could take.
Correct. If you choose a random sample, what is the possibility of X value? Here, higher X values are expected more often compared to smaller X values. So how many syntax you learn? D binom, P binom, and R binom. Now let us see the last syntax, Q binom, before I go to real problem. Suppose I have n is 6, p.32 in a binomial distribution. So this is a new question, not in your handout. So the probability distribution is given. Now, find x is equal to k. Look on the screen, all of you. Find x is equal to k such that probability is greater than k 0.35. So what it is 0.35?
So the probability.
Binomial probability. Meaning, find the value of k above which the binomial probability in the sample is 0.35 is the meaning. If above k 0.35 be less than or equal to k, it will be how much?
0.65.
Correct. Because we have learned the binomial probabilities are either individual probabilities or cumulative probability from minimum to the cutoff point. So here cutoff point is k. Probability from minimum to the cutoff point is 0.65. Find k. So reverse way. So far, P binom, D binom we have used to talk about probability evaluation. Now this is a reverse way. Given the cumulative probabilities, find out the cutoff value. Q binom 2. So what is the meaning k equal to 2? Anybody?
So it means that if if W is greater than 2, then the probability will be 0.35.
Perfect. And less than or equal to 2?
Less than
0.65 is
it would be 0.6.
Finished. So the total probability will be divided into 2. Greater than 2.35, less than or equal to 2.65. Who does it? Q binom.
So, sir, Q binom stands for the cutoff point.
Correct. Exactly correct answer. Earlier, X is given, find the probability. Whether it is D binom, P binom, we can do all algebra. Here it is reverse way. Binomial probabilities are given, find out the X value. This type of concept is used in a real example. So clear all the 4 syntax?
Yes, sir.
Is it clear all the 4 syntax? Only few students are answering. What about others? I don't know exactly. Shubham,
Sir?
clear?
Yes, sir, it is all clear, sir.
So just one question.
Yes.
For the variable k, where did we get the 0.65? I missed that part.
Array, question is, find out k. Dekho question. Find x is equal to k such that above which probability is 0.35. Okay. Is it okay?
Yes, yes, I got it.
But in our binomial function, we are always have cumulative probability from minimum to the cutoff point. No?
Yes, sir.
So, reverse way the probability will be 0.65 cumulative from minimum to k. Rather, I can rewrite this as is it clear now? Is it clear?
Sir, I think you have used the wrong sign. It would be less than.
Sorry. Yes, corrected it. This is the meaning. And this is what we so far doing in our earlier examples. So Q binom will give you k for probability 0.65 is the syntax. Same way, you can talk about reverse way probabilities. Okay, now it's clear. Okay. Now, so all the 4 syntax I have explained you for binomial. Same way normal distribution, but the variable is continuous variable. No change. Instead of binom, you can talk norm, t norm, p norm, q norm, r norm. What does it mean? Suppose in the question paper you see first. Let us share the question paper. A real life example I will show you afterwards. Now see the normality. Normal probability distribution is a non-discrete probability distribution. Measurable. Graph of normal probability distribution is always a bell-shaped graph, symmetric graph. And the point of symmetricity is mu. The only parameter is mu and sigma. Rest of the syntax is just like your binom, p norm, q norm, d norm, r norm. Now you should be faster. Name of the distribution will be added in the function. Let us do question number 1. A market research company employs a large number of typists to enter data into a computer. A large number of typists means say 500, 1000, 300, whichever it may be. It is observed that average typing speed 90 minutes with a standard deviation of 18 minutes. Find probability for greater than 120 minutes, greater than 78 minutes, between 67 to 98 minutes. Find K such that 20% of the typist has the completing speed below K. Look, question is exactly similar to that of binomial, but here the variable is a continuous variable, measurable variable, typing speed. Shall I continue or you want to make a meaning of the question? So this is what I am explaining now. Let me share now R. Given that mean is 90 minutes, standard deviation is 18 minutes, find out the probabilities for greater than 120 minutes. greater than 78 minutes, between 67 and 98 minutes. Meaning of the question is, suppose 350 typist came for the test. Average 90 and 18 minutes. So R-norm tells you typing speed of 350 typist, random sample of 350 typist. Clear now? Plot the data. What can be the shape of the graph then? Anybody?
It's a bell shaped.
It's a bell curve.
Correct. This is what normal distribution. For which value of the speed more typists are concentrated?
90.
Around 90 minutes.
And can you explain me an interval where more typists are having the speed? Roughly.
Sir, 72.
62?
120, I guess.
60
Yes.
to 20, yeah.
So this is the meaning given in the question. This is what the nature of the speed of all the 350 typists. How many came that we don't know. But I am telling you, large number means say 350, 400, 200. This is what the experiment on the typist. On this, find out the probabilities. The mean is at the center. Mean is at the center. And the first probability we want above 120 minutes. And the probability for the first option will be PA. Is above 120 minutes. Can anybody tell me the syntax? Just like binomial? Anybody?
You know,
So you want the
One.
probability above
Yes.
120?
Yeah, 1 minus,
1 minus P norm 120, 98 minutes.
yes. So along with the graph, I get the answer. How many percentage of typists are having the speed above 120?
So for
yes, 0.04.
4.7%.
So the answer is 4% approximately, correct now? Approximately 4%. Next, above 78. Above 78.
The same as above.
Right.
Oh.
Instead of 120, you have to go for
78.
correct. So again, I can plot that on the graph. AB line vertically equal to 78, comma, so color equal to green. And the probability will be same way 1 minus and the answer will be so much. Now between 67 to 98, the color I will change, yellow. Between the two yellow line is the probability. And that is your C part. P binom up to 98 minus P norm up to 67. And the answer is so all the probabilities are computed by P norm. R norm tells you generate the binomial as normal data. D norm tells you individual probabilities for the data. See the cutoff point. Find K such that X less than K 20%. %20% of the typist have the completing speed below K. What is K? Q norm. Q norm. So the K value will be shown on the graph with a black line. See, that is K. Find C such that 15% of the typist has the speed. So 85% of them have below C. Again Q norm. Plot it on the graph. Another black line. So the answers what we have numerically and we have on the graph. Answer I computed by using all the syntax and can be shown on the graph as well. So in your test, this much you have to know because the test is just 20 marks. I cannot ask more. But these syntax you have to know. So before you choose the correct option, first of all, you prepare the screen of your output. Then read one by one. Don't be in a hurry. Read the general question once, prepare the output accordingly on the screen, then read the sub-questions one by one. Choose the answer. So even if we give you 1 hour, it can over within half an hour even. But correctly, you have to know the different R functions and working. Find the central 50% interval. What does it mean? Anybody?
So what confidence interval? So we is a where we can say that the true value of the mean would lie between these two
Yes.
digits.
Yes. So if I say 50% interval, then what will you do?
So you find the 25th percentile and the 75th percentile and you find the range.
Yes.
Finished. That's all. Meaning,
Sir, that our maximum data would lie within that range.
right.
No, Rahul, I don't agree with that.
IQR, what does it represent? Like the
50% data will be within A and B.
Yeah, exactly, 50%,
Okay.
not majority data, like exactly half.
Yeah,
Yes.
half data would be within that range. Right?
Suppose if I say central 90%, then majority.
Yes, sir, got it. Neil is right.
So find out the interval A comma B, below A 25%, above B 25%. That is 25th percentile and 75th percentile. You know. Plot it. Finished. This is called quartiles.
Sir, can you
Q1
please
and
explain this?
Q3.
Sir, can you please explain this again?
Yeah. Central 50% of the data, central value. Center में. So center में 50% मतलब below left 25%, above right 25%. Correct na?
Yes, sir.
That is what asked for cutoff point A and B. Below 25% cutoff point is called 25th percentile. Above right cutoff point is 25% is called upper 75 percentile. You know. You can
Okay,
compare.
got
Is it related to confidence level, like upper confidence and low?
This is somewhat like our level of significance in testing.
Okay, sir.
Do you remember
But,
that 5% I divide into left and the right and the center?
Yes, sir, I remember.
So these all practices are for data analysis. So this is the way that we are working with introduction of binomial and normal distribution. Only difference, binomial is countable data, normal distribution is measurable data. Binomial distribution is countable data and normal distribution is for measurable data. P binom, P norm, D binom, D norm, R binom, R norm, Q binom, Q norm. So, whenever a problem comes, first you have to understand what you are supposed to do. Accordingly, write the syntax and algebra. So that is logic. Once the syntax is explained, you are able to apply the algebra on it and you can work. Clearly, I have shown to you computational work as well as graphical work. See,
Sir.
initially there were 71 students, now only 63. Where this 8 has gone?
Sir, I guess few from other departments have also joined, so they left.
That way.
Yes, I have seen 2-3 people.
Maybe some PhD students are also attending the class, it seems to be. Because they also have given the assignments. Okay. So, let us see.
Sir, you received MSc Eco assignments?
Yeah. Today the class is for financial economics and general economics, isn't it?
Yes, sir.
Yes, sir.
One thing. In general economics, I want to know about these two students. Savi Agarwal, 2031. He is present. Yes. Savi Agarwal. Where is she?